Okay, welcome to this video where we'll be having a look at a collection of topics that are unseen topics yet from papers 1 and 2. This will follow the normal structure of our previous videos, whereby the first part of the video is going to be going through the crossover topics that can appear on foundation or on the higher tier, and then at a point in the video it will swap to higher tier only, where if you are doing foundation you can obviously switch the video off, or if you're doing higher you can obviously watch through the entire thing. Now obviously this is just a collection of topics, it's not all of them. I have tried to prioritise questions or topics that don't appear within my practice paper. Some of them do, but just in different forms. For example, if you are doing higher, there is a quadratic simultaneous equation in one of my papers, but at the end of this video I also go over a very challenging quadratic simultaneous equation that's written in a slightly different form. So there are little questions like that, but this doesn't cover everything, it just covers some of the key priority topics that I'm going to be doing with my own students also. But do make sure that you check out the videos in the description and the latest videos on the channel where we've run through some practice papers, and always don't forget the night before the exam we will be doing another practice paper as well that has some different topics that don't appear on the first practice paper. So there's lots of content for you to use, hopefully you find them all useful and helpful, but we'll get started with this video. Okay, so for an error interval, this one here has been rounded to 1 decimal place. Now we can visualise this on a number line. The 1 decimal place above and below 9.4 would be 9.5 and 9.3. Now when looking at error intervals, we're looking at the cutoff points in the middle of those. So between 9.4 and 9.5 is 9.45, and between 9.3 and 9.4 is 9.35. Now when we're writing the error interval, sometimes we're given a letter, sometimes we're not. Here we're given the letter M, and we have our arrows pointing to the left. The left arrow has that extra line underneath it. Our lower bound goes on the left, 9.35, and our upper bound goes on the right, 9.45. So there we go, lots of different types of error intervals, but that there is a very common type of question looking at an error interval. With laws of indices, we've got multiple different rules that we need to know. So when multiplying with the same base, we have to add the powers. So here, m to the power of 3 plus 4 is m to the power of 7. When we're in brackets, we multiply the powers, and if any pieces inside the bracket don't have a power written with them, we can put a power of 1 with those just to help our multiplication. So here we get 5 to the power of 3, n to the power of 3, and p to the power of 9. Just watch out because numbers do need to be simplified there, so 5 times 5 times 5 would give us 125, and then we have n to the power of 3, p to the power of 9. With our division, the normal numbers within this one are divided as normal. So 32 divided by 4 is 8, and then we subtract powers. So here we have q to the power of 9 take away 3, which is 6, and r to the power of 4 take away 1, and that would give us r to the power of 3. And there's some of our laws of indices. Expanding and factorising is a key topic that appears in lots of different places. So here I'm going to use this method where I times them both by x, and that gives me x squared minus 9x, and then times them both by the 5. So that gives me plus 5x minus 45, just watch out for your symbols there, and then simplifying the middle two, negative 9 add 5 is negative 4, so minus 4x minus 45. When factorising here, we're looking for two things that will come out of the bracket as we are given this word fully. Now they both divide by 3 and they both have an x in. So 3x goes outside the bracket. To get back to 9x squared we'd have to times by 3x, and to get back to 6x we'd have to times by 2. And there we go, that's fully factorised. Okay, so for a frequency polygon, there are a few things you could be asked about the table. This one here is asking us to find the class interval that contains the median. So for 80 plants, we're going to have a look at where that halfway point is. There are two ways to look at this, but typically we can just divide that by 2 and find where the 40th plant is. Now if we count down cumulatively. So 7 add 13 gets us a total of 20. Add the 14 gets us to 34. And then we go past 40 on this next one, we get 46. So as we've gone past 40, our median is in this category just here. So we just write down that category between 40 and 50. For part B, it does ask us to draw the frequency polygon. To do that, we plot using midpoints. So for each one here, we want to identify the midpoint. They tend to be in nice even intervals here. So you can see each time it's just between the two tens. So nice and easy for you to find those medians. Just make sure you check on your graph very carefully where those median points are. So just in between all of these, you can mark them on before you start plotting them if you want. And then we just need to plot them on those frequencies. Check the scale very carefully. This one here, 2 squares is equal to 1. So I just need to be very, very careful when I plot these. And there we go, nice little cross on each one, marking them really clearly, and then we're just going to join them up with nice straight lines, and that will be completed. There we go, I can just about get these all in the right place, and then we have 16 up here, and the last one is 18, which is just below the 20, so that's there, and then we join that up, dot to dot. Nice straight lines, no curved lines here at all, no joining them up from the first to the last point. We are just going dot to dot from left to right, making sure that we join all those points up. And there we go, there's our frequency polygon. Obviously just make sure that your lines perfectly join up and connect those points there. I've actually just slightly missed this point as I'm doing it on the screen, but just make sure that when you're doing it, it's absolutely perfect when you're joining those together. And there we go, there is your frequency polygon. Now, fractions are typically a non-calculator style of question. However, we can have these types of questions where it says show that. So the show that type of question does require you to actually do the working out, and therefore you can't just type it into a calculator. So just be really, really careful with that language. Of course, that can apply to any type of fraction. For this one here, we have an addition in question 1. When adding fractions, we need to make a common denominator, and they need to be in written as improper fractions. So the first one, 1 times 5 add the 3 is 8 over 5. The next one, 2 times 4 add 1 is 9 over 4. It's exactly the same for addition or subtraction. We just need to make a common denominator. So showing very clearly how we're going to do that. So I'm going to times the left by 4, right by 5. That gives me 32 over 20. And it gives me 45 over 20. And we add that together. 50, 60, 77 over 20, and then here is the part where you have to be very careful. Now typically, of course, if you were just going to do this on a calculator, you could literally just type that in and it would now give you the simplified form. And 77 over 20 is in its simplest form, but we're going to have to write it as a mixed number. So we're going to have to show very clearly how we've done that. So 20 fits into 77, 20, 40, 60 fits in 3 times, and there's a remainder of 17. Now there's not really an easy way to do that on your calculator. If you type in 77 divided by 20, you'll get 3.85, which does at least tell you that there is a whole number 3, but you still need to work out that remainder. I guess you could then do 3 times 20 and see what was left over, but hopefully sort of calculations like that you should be fine with anyway. But there we go, 3 and 17 over 20 is our final answer. For the division question here, again, we take the same approach. We need to make sure that they are written as improper fractions. So 2 times 3 is 6, add the 2 is 8 over 3, and we're dividing by 6. Now, as we are doing a division, I would write that as 6 over 1, and therefore we can now do our reciprocal, or multiply by the reciprocal, and we can show that we are going to do times 1 over 6. Now again, if we type that into our calculator, it will get us straight to 4 over 9, but we're trying to show that it equals 4 over 9. So let's just apply our normal rules, times the top, 8, times the bottom, 18, and it allows us to show that we're now going to divide by 2, which is going to get us to that 4 over 9. So it's just watching out for this show that, making sure that we actually do show the steps that we're being asked to show. And there we go, there is some fractions. So you need to know the difference between simple interest and compound interest. Here we're going to look at simple interest, where we get the same amount of money every single year. So here we had £600 for 5 years and got £75 simple interest. So if we got £75 simple interest, we can do 75 divided by 5, which is £15. So that's the amount of money we got every year. If we want to work that out as an annual rate of simple interest, we can write it as a percentage. Like we would with a test score, we got £15 out of the £600 that we put in. On the calculator, we can then times that by 100 and it will give it to us as a percentage. So 15 divided by 600 times your answer by 100 and you get 2.5%. So there we go, our annual rate of interest here is 2.5%, and just remembering that simple interest is where you get the same amount of money every single year. Now for a scatter graph, the big thing straight away, as soon as you see a scatter graph, draw on a line of best fit. Now a line of best fit on a scatter graph is just a nice straight line that goes in the general direction of the points. Now typically that line will have some points above and some points below. So I've just freehanded a line there. Obviously you would do that with a ruler and a pencil, and you can see that there's a few points below and a few points above, and it goes in that general direction. So there we go. I'm happy with that line of best fit, although it could be slightly different for different people, and that's fine as well. Now this one says Jamie got a mark of 34 in the science test. Use the scatter graph to work out an estimate for his mark in the maths test. So we want to find 34 on the scatter graph, again being careful of the scale in this question, and then we're going to trace up to our line of best fit, and this bit of working out is really important because we are reading from our own line, which does allow us to have a bit of a variation of our answers, and that for me comes out as 39. So my answer for this would be 39. I've showed it nice and clearly using my line of best fit. You can be asked a few things about a scatter graph. So we can be asked about the correlation. This one has a positive correlation as it's sloping up. We can be asked about the relationship. This particular scatter graph shows that the increase in science marks, or as students got higher science marks, they also got higher maths marks. So when you're describing a relationship, you're actually looking at the context of the question and writing about what it shows. You can also be asked about things like outliers and why they're there. So something like this, you could have an outlier that's nowhere near the points, and maybe you would say, well, this is just somebody who does better at maths than in science. And sometimes you can be asked to give reasons for them like that. But there we go, there is a scatter graph and all the little bits and bobs that you can be asked about them too. Now we've already looked at a median from a table, but this one's looking at estimating the mean from a table. Watch out for that word estimate. In this case, it's not asking us to round anything. It's an estimate because we only have categories here. So when finding the mean, which is just timesing across, getting the total, and then dividing by how many there are, in this case there are 20 people, well, we have to use the midpoint, and that's why it's an estimate. So the midpoint for that one would be 200. If you're not sure on the midpoint, you can add the two numbers together and divide it by 2, nice and quick on your calculator. We have 300 as the midpoint here, 400, 500 and 600. So nice, sort of rounded numbers there, nice and easy for us to now times across. 1 times 200, 11 times 300, and again, you can just use your calculator for this. So as I'm sort of writing these numbers down relatively quickly, of course, you would just be typing them into your calculator. 400 times 5 is 2,000. 0 times 500 is 0. Watch out for those zeros in these. And then 1,800. We now want to add all of those together. Again, when you do type these into the calculator, just be super careful. It's so easy to type a number in incorrectly, but that one gives us 7,300. Now this final step, don't rush it because we do want to make sure that our answer makes sense. So 7,300 divided by 20, which will give us our mean, and that for me comes out as 365. So my mean, and I'm confident that mine's correct there, is 365, and I'm confident that it's correct because 365 is in this category here, which is somewhere close to the middle. It normally is when looking for the mean, unless you've got a huge amount in the first or the last category. And the answer makes sense. It's not outside of the range 150 to 650. So there we go, £365 is the estimate for the mean from this table. When looking at sampling, we are essentially going to be working out a fraction or a percentage of an amount, depending on how we look at it. But this one here says that there are 100 people asked which type of chocolate they like best. So this is out of 100. It says the shop is going to buy 6,000 chocolates next week. Work out how many dark chocolates they should buy. Well, if we look at the dark chocolates just here, then there's 40 out of 100 people in this sample wanted dark chocolate. Now that equates to 40%. So what I could do is I could take my 6,000 and I can either work out 40% if you prefer to do percentages, or I can work out the fraction of the amount. Now the fraction might not always be a nice percentage, as this was out of 100 is a nice percentage, but I can work it out as a fraction regardless, so up to you. I can either do 6,000 and then divide that by 100 and times it by 40, and I can just do that on the calculator. So divide by 100 times 40, and that gives me 2,400. That was me doing a fraction of an amount, or I could do 6,000 and I could just times it by 0.4 or 0.40, depending on how you want to write it, and that'd be working it out as a percentage. And there we go, my answer comes out as 2,400, and that is looking at some sampling. Now, of course, sometimes we make assumptions when doing this sample, and we are making an assumption here. We are assuming that the sample represents the rest of the people that are going to come and buy these chocolates. But there we go, there is some sampling. Now when looking at sequences, this particular question, we are looking at working out the nth term of a sequence. So always find the difference between the terms. Here it goes up by 6, and then up by another 6. This means it's related to the 6 times table, which means our nth term starts with 6n. The only thing we need to figure out is how different it is from the 6 times table. The 6 times table starts with 6, and to get from 6 to 7, we would have to add 1. So here our nth term is 6n plus 1. On part B here, we're asked that a different sequence is given the term 8 minus 6n. Is negative 58 a term in the sequence? And you must show how you get your answer. Now you can solve this by making an equation, but it's actually quite nice just to substitute values of n and see if we get close to negative 58. Using a bit of logic, 6 times 10 is 60, so if we do 8 take away 60, which is when n equals 10, and we can type that into our calculator, and for that one there, we get negative 52. So we're pretty close, so let's go to n equals 11, which is 8 take away 66, and that actually gives us negative 58, so our answer would be yes. Of course, if it didn't land on that number, we would give the answer no. You might see that it's just in either side of the number that you've been asked to see if it's in the sequence. But there we go, there is using nth terms as well as finding nth terms. Now with angles in parallel lines, of course you just need to be very careful here, make sure that you know all of your different angle rules. You have your alternate angles that make that almost Z shape, you've got corresponding angles that make that F shape, you've also got co-interior angles, which are when they are inside, so that 125 there is co-interior with this one, and they add up to 180 degrees. Now typically these questions are only asking you to find some particular angles, but if you look at the diagram, try and have a think about is there any other angles that you can find straight away anyway, which might just open up the question. So before we even look, I can see that that is a co-interior angle, and I might not need it, so I don't want to waste any time, but if I can see them nice and quickly, I can always fill in some of these angles. I can see that's 2 angles on a straight line there, and then we also have this one here, 2 angles on a straight line. Then there's others that I can go from there, but this does say show that ACD is an isosceles triangle. Now this is ACD just here, and an isosceles triangle has 2 angles that are the same. So I want to prove that 2 angles are the same. Well, I've already got that 55. These are vertically opposite angles, so that would be 55 there as well. And then I want to find this final angle, 180, take away the 70, plus the 55, the 2 angles that we've just worked out. Again, I'm just going to type that in on my calculator. 70 plus 55, take it away from 180, and that equals 55 degrees. So this is an isosceles triangle. Again, it did say show reasons for each stage of your working. So this one here, we had co-interior angles. Sum or add to 180 degrees. We had vertically opposite angles are equal. We had actually quite a lot of rules here. Vertically opposite angles are equal. We had angles on a straight line equal 180. And then to finish it off, we had angles in a triangle. I'm going to write sum to 180 again, but we had angles in a triangle adding up to 180 as well. Now you might want to write for something like this where it says show that it's an isosceles. You'd probably want to write some sort of explanation here along the lines of two angles are the same, and in an isosceles two angles are the same. Of course it's the base angles, but this one here is rotated on its side slightly. So there we go, two angles are the same, therefore it is an isosceles. So when looking at best buys, we want a comparable amount for both things. Here we're trying to buy 15 rolls of wallpaper and we have two different options. So here, if we have 3 rolls, we'd have to times this by 5 to get our 15, and £36 times 5 is £180. On the other option, we can buy packs of 5, so here we'd have to times this by 3. But we do also have this 12% discount which we can have as well. So £70 times 3 gives us £210, but we're also going to have to work out what that costs then after the discount. So for 12%, which is 100% minus 12, which is 88, we can use any method to work out 88%. I like to just use a multiplier and times by 0.88. So that's going to decrease it for me. That's going to give me the reduction straight away. So times by 0.88, and that gives me the answer, which is £184.80. We just need to write down the exact place that we need to buy it from to make sure that we get the cheaper option. So here we go, making sure that you're working out is super clear and backs up the answer that you're giving. Now a Venn diagram, of course, gives you some numbers that you're allowed to put into the Venn diagram. This one here, we are allowed to use the numbers from 1 to 10. It then tells us out of that, the even numbers, 2, 4, 6, 8 and 10 are going to go into A, and the factors of 10, 1, 2, 5 and 10 are going to go into B. Any numbers that are in both, we're going to put into the intersection. So there's a 2 that goes into both and a 10 that goes into both. So 2 and 10, and we'll cross those off our list. For A, we have 4, 6 and 8, which are still going in A, cross them off the list. And we have 1 and 5, which go into B. And again, we'll cross off the 1 and the 5, and any numbers we've not crossed off, so 3, 7 and 9, will go into the outside. Quickly count those up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we know that we are only allowed the numbers 1 to 10. So 10 numbers, no repeats, happy with our Venn diagram. We do have some different aspects of set theory that we can be asked about. This particular one is asking about A and then the intersection B. Now the intersection symbol is asking us about these numbers in the middle here in the crossover part. That's the intersection. So the probability that it's in the intersection, well, there's 2 numbers there and there's 10 numbers in total. I don't need to simplify that, you can do, but if you're going to simplify a probability, make sure you just type it in on your calculator, it'll simplify it for you, or just leave it. You don't gain any marks for simplifying it. You could also be asked about the union. The union is your little U symbol, and the union represents all of the numbers in the circles all together. You can also be given things like A dash, which means not in A. Now the number's not in A, you've got the ones just in B, and you've got the one just on the outside here, but you wouldn't be allowed any numbers there that are in the A circle. So lots of different bits that you can be asked about with the Venn diagram. This one was looking at the intersection, and there is your Venn diagram. Inverse proportion in context is often a question that catches people out. Here it says it'd take 30 hours using 4 machines. Now if we write that down, we want to normally figure out with all types of proportion exactly how much one would sort of take or cost or something along those lines. Here it is about time, but here to get down to 1 machine, it would take longer. So we're not going to divide by 30 or divide by 4. Here, to find the value of 1 machine, we're actually going to have to times by 4, as it's going to take 4 times as long. So 30 times 4 gives us 120 hours, and it makes logical sense that it would take 4 times as long. But notice here, on the right we're dividing by 4, and on the left we're timesing by 4, and that's what makes it that inverse proportion. So here as well, now it's asking us how many machines are needed to make all the plates in 6 hours, so we want to know how do we get down to 6 hours. Well, to get down to 6 hours, we have to divide by 20, which means over here, we're going to times by 20, and that's going to give us 20 machines. So just watch out for these questions here. You just have to think logically, does it make sense that less machines would take more time or less time? And obviously that's what we're figuring out in this middle step here, where we've looked at this 1 machine. It makes logical sense that less machines would take more time. So there we go, that's some inverse proportion in context. So you need to make sure that you know your different types of graphs. Here we're asked to identify a cubic graph and a reciprocal graph. Now there are two cubic graphs, you've got B and you've got F. The graph of x cubed, just on its own, passes straight through the origin just here and only the origin. So that is graph F. For part B, it asks us to find a reciprocal graph. Again, there are two reciprocal graphs, but this is a positive 1 over x, so we're looking for the reciprocal that's in the positive quadrant of the graph, and that is there in graph D. You also have an x squared graph in part A and a y equals mx plus c style graph, the straight line graph, in graph E. But there we go, there's some different types of graphs. Pythagoras Theorem is a really key formula that you need to know, a squared plus b squared equals c squared, where c is the longest side, the hypotenuse. Here we're actually given the hypotenuse and we're asked to find one of the shorter sides. So I need to do a subtraction rather than an addition, so I take the 8.5 squared using the bigger number first, subtract the 4 squared, and I'm going to work out what that is, 8.2 squared, 8.5 squared, take away 4 squared, and that equals 56.25. Now that's the value of a squared or b squared, depending on how we wrote the formula, so we do have to square root our answer. Again, doing that on the calculator, and this one here comes out as 7.5. Look at the units in the question, that's 7.5 centimetres. And there we go, that's using Pythagoras Theorem. Just watch out, because Pythagoras can appear within other topics as well, but that is a nice little Pythagoras Theorem question. So with a simultaneous equation, you can either look at the coefficients of x or the coefficients of y. I always look at the coefficients of y, and I'm going to make those the same. So 2 and 3, the lowest common multiple is 6, so if I times the top equation by 3 and the bottom equation by 2, those coefficients will be the same. Remember, everything's getting times by 3, so it becomes 15x plus 6y is equal to 33, and on the bottom there we have 8x plus 6y is equal to 12. Now when the symbols in the question, or the two equations, are the same, we subtract these equations. So the same symbols we subtract, otherwise we add them together. So I'm going to look which one has the bigger numbers in. So 15x, I'll do 15 take away 8, which gives me 7x. And I'll do 33 take away 12, which gives me 21. That means now, look, when I divide by 7, I get a nice number here. We get x is equal to 3. Of course, remembering you can get decimals, you can get negatives, you can get negative decimals in this scenario here. If you do, that's fine, because we're going to be using a calculator for this. So if you do get that, don't panic, they can come out as decimals. Now I've got x is 3, I need to substitute it back into one of the equations. It doesn't matter which one. If there is a negative in the equation, I tend to try and avoid that one. But if we substitute it into the first one, we get 15 plus 2y is equal to 11. I can now subtract 15, which gives me 2y is equal to, and 11 take away 15 does give us a negative, we get negative 4, and when we divide that by 2, we get y is equal to negative 2. And there we go, there is our simultaneous equation. I want to write down both the answers, so x equals 3, and y is equal to negative 2. And there we go, there is a simultaneous equation. Now with speed, distance, time, similar to when we were looking at density, we need to make sure that we write down the formula. Speed is equal to distance divided by time, and again we can use a formula triangle for that. So speed, distance and time. This one says Riley travelled by car and by aeroplane. He travelled 143 miles by car, and it gives us the speed. He then travelled for 5 hours and 20 minutes by aeroplane. Work out in hours and minutes Riley's total time travelling, or total travelling time. So here, well, we already have his travelling time for the second journey, 5 hours and 20 minutes. We just don't have the time for that first part, but we are told the distance and we are told the speed. So we can work out time. If we cover up the time on our formula triangle, this distance divided by speed, we just need to watch out, make sure we get this all in the right units. So we've got miles and miles per hour. They're in the same units. So the distance of 143. We can divide by the speed of 55, and if we do 143 divided by 55, it gives us a fraction, 13 over 5, or 2.6. Watch out for recurring decimals here. This one doesn't have a recurring decimal, but if it does, of course, we just want to multiply this by 60 to turn it into minutes, or we can just take the decimal, so I can do 0.6 times 60. Again, this is where you have to be careful if there is a recurring decimal that you don't miss that. But 60 times 0.6 is 36 minutes. So that's 2 hours and 36 minutes. Now, of course, this was looking at the total travelling time, so we also have the 5 hours and 20 minutes. Now, as it turns out, this gives us a nice amount of minutes because the 36 and the 20 is not going to go over the 60 minutes. So when we add these together, we get 7 hours, and 30 and 26 makes 50, so 56 minutes. So obviously just be careful there, if that does go over the 60, that will of course turn into an additional hour, and you'll have some extra minutes left over. But this one didn't, so 7 hours and 56 minutes for our total travelling time. Now, there are lots of different methods to use for compound interest. This particular one here, I'm going to use a multiplier, but you can use other variations and even different methods of using the multiplier. So we've got £25,000 for 3 years in a bank. We have the personal bank, which offers 2% compound interest each year, and then secure bank, where the interest changes from 4.3% to 0.9% after that first year. We want to know which bank gives the most interest after 3 years. Well, if we go for the compound interest for the personal bank, we have £25,000, and the multiplier for 2% is 1.02. Now, typically with compound interest, it's always 1.0 something, but if you're not sure, you can add the 2% to 100, which is of course 102, and then you just divide your answer by 100, and that comes out as 1.02. You may recognise them. Of course, there is another way you could do it. You can actually just type in 102 and use a percentage button on your calculator, which if you've not seen, try and find that. It's normally behind the answer button, and you press equals, and you get 1.02, and it gives you the multiplier for you. So 1.02, and we want to put a power of 3 for 3 years. So 25,000 times 1.02 to the power of 3, and that comes out as a total amount of £26,530.20. For the other bank, we have 2 different percentages. So we'll have 25,000. This time we'll times by 1.0, and it'll be 43 for 4.3%. And again, you can use either of the methods in the top right there to find that multiplier. And that's only for the first year. So I could work that out and then deal with the next one. But as I'm going to go straight onto the next one anyway, I can just times by the next multiplier, which will be 1.0. And this is a weird one because it is less than 1%. It's actually now going to be 0.9. So it's quite a small number there in terms of the multiplier. And that's going to be for 2 years. So a power of 2. Again, I just want to type that in. I've already got the old one typed in, but that has a power of 3, so I'm going to have to get rid of that. 1.043 times 1.009 squared, because we're getting that for 2 years, and that comes out as £26,546.46. Now, this one does say which bank gives the most interest, so I don't necessarily have to calculate the exact interest there because they have the same amount going into both. I don't need to. I can just have a look at which number's the biggest. So this one here, secure bank, we've got £16.26 more, so we would say secure bank as our answer here, and we've got all the working to show that. Just watch out, if it does obviously give different amounts, you would need to subtract the 25,000 from those amounts and actually say the exact amount of interest for each one in order to make that comparison. But as this one had the same starting amount, we could just have a look at the biggest number. And there we go, that was some compound interest. Now, pressure, force and area is nice in the sense that you are given the formula. Now, typically you'll be given either a diagram or, like this one, you've got no diagram. One of the common questions which is coming up is actually asking you to find out the area of the base of a shape. This one here says it's a box in the shape of a cuboid. You can always draw a picture for that. It doesn't need to be an amazing diagram, but a cuboid's relatively nice and easy to draw. It says the box exerts a force of 180. Now, if you're going to write it into the formula, that means on the top here we've got the 180, and there's a pressure of 187.5. The face in contact with the floor is a rectangle, and it has a length 1.2 and a width of x. So here, as we mentioned, there is a missing area. Now, you can write the formula into a formula triangle like we did with speed and density. Pressure, force and area. If you want to work out the area, cover up the A, and it's force divided by pressure. So the force is 180, the pressure is 187.5. So we can type that into our calculator. That's going to give us the area, 187.5 on the bottom. It gives us a total area here of 0.96. Now the units are in metre squared, so that's metre squared. You don't necessarily need the units at this point. We just need to know that that is the area of the base of this shape. So 0.96, and the width is, or the length is 1.2. Now that means it's 1.2 multiplied by the width, which is equal to 0.96. Of course, you could just write that as 1.2x. Now to solve that, we would just need to divide by 1.2, and we would have our length of x, which is 0.96 divided by 1.2, and that comes out as 0.8. So there we go, the value of x is 0.8, that's the width of the rectangular base. Now for a vector diagram, typically this one here, it could give us the vectors, this one hasn't, we have to find them ourselves. So from here, we look from the start to the end of the line, that goes 1 across and 2 up. So A is the vector 1, 2, and B, here's the start, here's the end, it goes 1 across, 3 down. So B has the vector 1, negative 3. And this particular question says, on the grid, draw and label the vector A plus 2B. So to work out A plus 2B, we would take A, 1 and 2, and add to that 2 lots of B. So if we times this one by 2, it's 2 and minus 6. And then we just add those top numbers and those bottom numbers. 1 plus 2 is 3. 2 add negative 6 is negative 4. As we are adding a negative, we just take away 6. And we just need to find a place where we can draw this. That means 3 to the right and 4 down. So I want to go somewhere where I can at least go 3 to the right. So maybe I could fit this in here. If I go 1, 2, 3 to the right, and then 1, 2, 3, 4 down, I end up just there. I want to join that up from the start to the finish, drawing a little arrow to show the direction that goes. You can label it if you want. I could label that A plus 2B, and there we go. There is my vector diagram drawn. Okay, so looking at a percentage change, it says here, Nimra buys a 3 kilogram box of sweets for £17.60. She puts the sweets into bags to sell, and each bag contains 150 grams. So straight away we can work out from this exactly how many bags she's going to sell. 3 kilograms is 3,000 grams, and we want to divide that by 150. So 3,000 divided by 150 comes out as 20 bags. So she's going to sell 20 bags of sweets. It says here she wants to sell each bag for the same price. Great. She wants to make a profit of at least 35%. What's the lowest price she should charge for each bag? Well, we want to work out this 35% profit. We can treat it almost as a multiplier, or we could use a non-calculator method, work out 35% and add it on. So for £17.60, I think the easiest way is just to use a multiplier like we do with compound interest, except we're just going to use a 1 multiplier. So 1.35 for 35%, £17.60 times 1.35, that tells us that she needs to sell all of these sweets for £23.76. That's to make at least 35% profit. Now she's going to sell all the bags for the same price, and she's got 20 bags, so if we divide that by 20, we've got the amount that she's going to have to sell it for. Now that comes out as, and let's just type it in, £23.76. Divide by 20, it comes out as £1.18 and an 8 afterwards. Now that means, because the little 8's there, if we only sold these bags for £1.18, and you can work backwards, £1.18 times 20, she would only get £23.60. So she wouldn't have the 35% profit, she'd have close to it, but it'd be just under. So we are going to have to round this up. She's going to have to sell them for £1.19, which is the smallest amount that she can actually sell them for, and £1.19 times 20 would give her £23.80, and she'll make that 35% profit, just over, but she makes at least 35%. So there we go, £1.19, and that was looking at a percentage change there. Okay, so from this point onwards, we'll be looking at the higher only content. So if you are sitting the foundation exam, the rest of the topics from this point will not be relevant to you. So hope you enjoyed the video, and hopefully I'll see you for the next one where we look at our practice paper the night before the exam. If you are sitting the higher paper, great, stick with me and we'll carry on. So be really careful with compound interest when we sometimes have these reverse compound interests. We can either be asked to find the actual percentage or asked to find the amount at the start. This particular one, we are looking at the number at the start, as it says that these people invested X amount of money. But it does tell us at the end of the 3 years, Louise's investment was worth $344,605. So Louise invests into better investments, offering 2.5% per annum. So we would take her amount of money, multiply that by our multiplier, which for 2.5% is 1.0 and then 25. As it's 3 years, that would have been to the power of 3, and it tells us the answer is 344,605. We can divide by this multiplier to reverse that calculation, and if we do that division, we get x is equal to 320,000. That means that both of these people in this particular question invested £320,000. So when we are looking at the next person here, which is Sadiq's investment, we can take the £320,000 and we can apply that to the other bank. So we have £320,000 in the first 2 years. He's getting 1.02 for 2% to the power of 2, and then after that gets 3.5%, so 1.035. We can actually type that all in one go, so times 1.02 squared times 1.035, and we get the final amount of money, which comes out as £344,580 and 48 pence. So that was using compound interest in reverse and then applying that and using it going forwards again. Okay, so in this question we're having a look at some reverse percentages, and this is about depreciation. So it says here that at the end of the first year a car had decreased by 12.5%, and then it decreased by 10% each year for the next 2 years, and at the end of those 3 years it was £17,010. We want to know the value of it 3 years ago. Now with depreciation, our multiplier, if we imagine this as a bit of a timeline, we have the start, year 1, year 2, year 3. Now each time this has been multiplied by something which is decreasing it in value. Now between year 1 and 2 and 2 and 3, that's quite a nice easy one. That's just multiplying by 0.9, which is 90% when you remove the 10%. The other one we'd probably want to use our calculator for, 100 take away 12.5 is 87.5%. So that is being multiplied by 0.875. So that's what we would do to reduce by 12.5% and then further reduce by 10%. We could write the 0.9 as 0.9 squared, as it's going down by the same amount for those 2 years. Now essentially at the end of the 3 years there, it's worth £17,010. So to go back in time, we would just do the inverse of these, which would just be dividing by 0.9, then dividing by 0.9 again, or of course you could write divide by 0.9 squared, and dividing by 0.875. So if we just do that in our calculator, we can just do it in single steps. We don't have to include the powers and sort of add those additional bits in. When we divide by 0.9, it becomes, and I'm going to write down each one as we go, 18,900. Then divide by 0.9 again, and we get to 21,000. And then divide by 0.875, and we get to £24,000. And there we go. That is a reverse percentage, where we were looking at something which had been depreciated and has now reversed back in time, back to that original value. Now a circle sector is treated in the same way as when we work out the area or the circumference of a circle, except we're only looking at a fraction of a full circle. This particular one is asking us to work out the area of the shaded segment, but to do that we'll first work out the area of the sector by doing pi times the radius squared, 5.4 squared, multiplied by the fraction of the circle we're looking at. In this case, that's 72 out of 360 degrees. So we can type that into the calculator, times 5.4 squared, times 72 out of 360, and that comes out as 18.32176836. Now to work out the area of the triangle, so we can take that away from the area of the sector, we need to use half AB sine C. So half AB sine C allows us to work out the area of a non-right angled triangle where we don't know the height. It also allows you to work out the area of a right angled triangle, but we typically don't need that because we do have normally the height and the base of those triangles. So here C is the angle that we're using, so in this case the 72, and A and B are the two sides that create that angle. So here we do half times 5.4, a nice method you can use because they're both the same. We can do 5.4 squared and then times sine 72. So if we type that into our calculator, you can use 0.5 as well when typing in a half, and then times sine 72, and that gives us the area of the triangle, which here comes out as 13.86640401. So the area of the shaded segment will be the 18.32. I'm going to type the whole thing in, but I'm just going to write that down. Subtract the 13.866 number, and let's type the whole thing in. So 18.32176836. Subtract the previous answer, and that comes out with an area 4.45536. I'm going to stop there because the question only wants it to three significant figures. So 1, 2, 3, and the answer there will be 4.46, as there's a 5 after the line. Now this is to do with area, so look at the units, it's centimetre squared, so that's 4.46 centimetre squared for the area of the shaded segment. So looking at some negative and fractional indices, which is a topic which tends to appear more on a non-calculator exam. However, there are these variations that you can't type into a calculator. So here we have, in our first example on the left, we have the problem where we're looking at similar base numbers. Now here, these are all powers of 2. 16 can be written as 2 to the power of 4, and 8 can be written as 2 to the power of 3. So this type of question is all about rewriting the base numbers to the base sort of power that we're looking at, and here we're looking at powers of 2. So that's 2 to the power of 4 to the power of a fifth, times 2 to the power of x, which is already a base of 2, and then we have 2 cubed, which is to the power of 3/4. Now powers in brackets just get multiplied, so 4 times 1/5 is 4/5. The 2 is just to the power of x, and 3 times 3/4 is 9/4, so 2 to the power of 9/4. So although the powers look more complex, we can just apply our normal laws of indices. So adding the powers of 2 when we're multiplying, we'd have 4/5 plus x, and that's equal to 2 to the power of 9/4. So now we actually just have to compare the powers. 4/5 plus x has to equal 9/4. So to solve this for x, we would do 9/4 and subtract 4/5. Now thankfully, that little step there we can actually type into a calculator. So 9/4, take away 4/5, and that equals 29/20. Or, as a decimal, 1.45. So I'll write the answer as a decimal there, just it's easier for me to write. But there we go, either answer there would be fine, 1.45. Now the second question is a reverse power sort of rule here, where we are looking again at powers in brackets, but we also have a fractional power. Now we're looking here to see what's changed, because there are missing pieces. It wants us to find the value of a and the value of n. Now the easiest bit for us to spot here was, well, the bit that doesn't work. A to get to 7, we don't know, because we don't know what root has been done here because of the missing n. So we've got 2 unknowns in that one, so that one's going to be a little bit more complicated to find. But if we look at the 3, and here it started with a 6, you can see there that the power has halved, and therefore the power in place of the 1/n has to be 1/2. It has to have halved the power. And we know we multiply powers in brackets, 6 times a half is equal to 3. So we know just by looking at that n is equal to 2. Now that allows us, so I guess we could rewrite it, just to make it a little clearer, that is now to the power of a half, and it equals 7x to the power of 3. Now we can look at the a, and how we get to the 7, because a power of a half does a square root. So here it's basically saying what number has been square rooted to get the answer 7. Well, 7 squared is 49, so 49 must be the value of a, and we can always write this. And if we work that out, we would do the square root of 49, which is 7. We'd have the x and the power there. 6 over 2 is 3, so we get 7x to the power of 3. So there we go, we get a is equal to 49 and n is equal to 2. Okay, so a cumulative frequency graph we plot on the endpoints. So when looking at your cumulative frequency table, just make sure whether this language is here, cumulative frequency, or it says frequency. If it says frequency, you're going to have to add them up as you go down, getting those cumulative totals. This one's been done for us, so we definitely don't want to add those up, otherwise it'll end up going off the graph. But we're going to plot on the endpoints, again being really careful with the scale here, onto 60, onto 25, 80, up to 35, 38 for our next one on 100, and then our final one landing on the 40. Now, do have a look at this starting number here. Don't assume that the cumulative frequency curve joins up to the origin. It doesn't. It starts at that first time, which is down here at 20. It's almost worth marking that number first. And then we join this up with a nice smooth curve going through all those points. And that's your cumulative frequency curve. You'll be asked lots of different questions on this. You can look at the median, the interquartile range, which we're going to have a look at here, or you can have a look to find certain values at certain times. Just read the question carefully. Here, the median, we would go along from 20, as that's half of 40, the total, and we would go across and read down. The interquartile ranges, we're going to find the halfway point in this first half and the halfway point in this second half here. Now that is going to be from 10, so we go across from 10, we go down, we read the value exactly as we get it. This one here for me with 50 in the middle there looks like, because that's going to be every 2, that's going to be 45 for my reading. And then if I go across from 30, which is halfway along in that upper quarter there, I try and draw my line down as straight as I can. That for me comes out as 62, 4, 6, 7, maybe 68 there. It's just going into. And you will have a range of values that you're allowed to work out here. For the interquartile range, I need to do the bigger take away the smaller. So 68 take away 45. And again, just little scenarios like this. I know that's an easy subtraction to do, but just make sure you use your calculator. And there we go, 23 for our interquartile range. Now with capture recapture, it's a really nice topic. We just need to write down the two proportions that we have in each capture. Now on Monday, we catch 90 bees. We put a mark on the bee and put them back into the hive. Now that was 90 out of a total that we weren't told. So that is the fraction of the amount for that particular capture. In the second capture, on Tuesday, there's 120 bees and 20 of them have been marked. So that's 20 out of the 120 that were caught that have the mark on. Now all we want to do is look at these and make them equivalent fractions. So how do we get from 20 to 90? Well, 90 divided by 20 on the calculator is 4.5. So that's going to be multiplying by 4.5. So to ensure that these are equivalent, we times the bottom by 4.5 as well. And 120 times 4.5 is equal to 540. So here, our estimate for the total number of bees would be 540, but of course we are just making an estimate here as we are assuming a few things like that none of the bees have died and that we have used sort of the similar methods, and there are different assumptions that you can give for questions like this. But there we go, that is using capture recapture to find those missing populations. So this question here is looking at the volume of cones and spheres. Thankfully, you are given the formulas for those, so they'll be next to the question. So have a look at your formulas, just make sure that you are super happy with using them, finding your pi button on the calculator, and we're just going to work out anything that we can see. So this particular one here tells us that the total volume of the shape is 120 pi, and the total height is y. So we are going to work out the value of y in this question. So here, when we're trying to find this missing height, well, we're going to have to work out the volumes. So if we go about working out one of the volumes, we can identify that we cannot work out the volume of the cone yet because we don't know the height. If we had y, then we could, but we do know the height here of the sphere or the hemisphere because it is the radius. So the radius goes from the centre of that hemisphere down to the bottom of the sphere here. So that's going to be half of the 7, so that's 3.5. So we do have part of the height already. We just need to work out that volume that's just the cone. So if we use the volume of a sphere formula, we have 4/3 pi r cubed. However, for a hemisphere, we can halve that as it's half of a sphere, and that's timesing this formula by a half. If we times it by a half, instead of being 4/3, and you can do this on your calculator, 4/3 times a half is 2/3, of course, half of 4/3. So 2/3 pi r cubed. So we can use that straight away. So 2/3 times pi times 3.5 cubed. That's going to give us the volume of the hemisphere. So we can type that in, 2/3 times pi times 3.5 cubed. That gives us a volume. It's not a particularly nice one. It comes out as 343 over 12 pi. So there we go. You could write the decimal version of that down if you wanted, but I'm going to leave it in terms of pi. So for this bit next, we're going to take that away from the total volume that's given to us, so 120 pi, minus this 343 over 12 pi, and that's going to give us the volume of the cone. So 120 pi minus the answer on the calculator, and that comes out as 1097 over 12 pi. So that right there is the volume of the cone. Our formula for the volume of a cone is right here, 1/3 pi r squared h, and all we need to do is work out the height. We have all the missing pieces, so we could set up the formula. We have 1/3, we're kind of running out of space here, let's do it down the side, 1/3 pi times 3.5 squared times the height is equal to 1097 over 12 pi. Just about fit it in there. And now to isolate the height, we can take all three of these pieces and divide those to the other side. So we get the height is equal to 1097 over 12 pi divided by, and then we have this 1/3 pi times 3.5 squared. Now I'd probably write that as a fraction on my calculator rather than as a division like that. Probably going to be a lot easier for us to do. So I already have the answer on my calculator, so I can put the answer over and then do 1/3 times pi times 3.5 squared. Now that gives me a final answer. It comes out as either a decimal or as a fraction. I'm going to write this one as a decimal. It comes out as 22.3877551. Okay, so that is the height of the cone, and to get the height of the overall shape, which we've got over here, we've got the 22.38, we're going to need to add the 3.5, which is the height of the hemisphere, and if we add 3.5, it comes out as 25.887. So 25.887, and we want that written to three significant figures. So that's going to be 25.9, and that's in centimetres. And there we go, that is our final answer, 25.9. So basically, just using your formulas, we had using the formula once, normally, for the sphere, of course only doing half of it though, as it was a hemisphere, and then we had a formula in reverse to find the height of the cone, and this one here wanted the height of the overall shape, so we've added those two together. And there we go, that's a bit of volume of cones and spheres. Okay, so for this question we're going to be looking at a circle problem, not necessarily a sector here, but a really nice little circle problem. Now it wants us to work out the circumference of a circle, and the formula for that is circumference is equal to pi times diameter, which means the problem here is working out the diameter. Now we have this rectangle inside the shape, and spotting the process for working out that diameter, I guess, is the challenging part here, because if we draw the diameter in, it creates a nice right angled triangle. Now there are a lot of bits of maths that we can use to work out the missing side in a right angled triangle, but if we have two of the missing lengths, then we can use Pythagoras Theorem. So a squared plus b squared is equal to c squared, where c squared is the hypotenuse. So a and b is our 8 and our 10, so 8 squared plus 10 squared. You can actually just square root that in one go, just saves you a little bit of time, and we'll get our answer for that diameter straight away. Now it comes out as 2 root 41. You can write it as a big long decimal if you want. It has 8 decimal places. I think it's easier just to leave that as a surd. So 2 root 41 is our diameter. Now that just makes it nice and simple then to work out the circumference, because the circumference will be pi multiplied the diameter, which is 2 root 41. So we can just times that by pi, and we've got our answer. It comes out as 40.23201,613. And there we go, there is the circumference of the circle. It does ask us here to give it to 3 significant figures. So if we chop it after that third significant figure, it comes out as 40.2 centimetres. And there we go, there is our final answer. There we go, we'll put the units for that as well. Okay, so for circle theorems, there are so many different types of questions that you could see. This one here involves a nice little selection of some different circle theorems. It asks us to work out the size of angle CDE. CDE is this angle here, and we have one other angle within the triangle. We've got the 16 down outside of the circle there. So this circle theorem, again, and knowing your circle theorems and just being able to spot here that that's an angle at the circumference, and here we have an angle at the centre, which means I can divide this angle by 2 and work my way up to that angle A. So 132 divided by 2 is equal to 66. It does say give a reason for each stage here. So for that one, I would write that angles at the centre are half angles at the circumference. From there, we can actually see that there is a cyclic quadrilateral. So a large quadrilateral here where all 4 points are touching the circumference of the circle, meaning that the opposite angles add up to 180. So I can do 180, take away 66, which means this is 114. Again, I would write next to that because opposite angles in a cyclic quadrilateral add up to 180. So I've got a few of these angles now. I've given 2 reasons. I just need to think about, is there another circle theorem, or can I start to get into my answer? Now I have a straight line, BCE, which means that next to the 114, these two add up to 180, so this would be 66. I now have 2 out of my 3 missing angles in this triangle on the outside. We can get our final answer doing 180 take away the total of 66 add 16. I can type that in one go. 66 add 16, take that away from 180, we get 98 degrees. I could give 2 more reasons in those final steps there as well. We had the 66 because angles on a straight line equal 180, and 98 because angle in the triangle adds up to 180. So we had 2 circle theorems and 2 just angle rules that we gave along with that as well. But there we go, there is one variation of a circle theorem. Of course, there are absolutely loads of different styles of questions, so I will link the video for circle theorems in the description. You can have a look at some different examples as well. Now, of course, there are lots of different questions with circle theorems, so here's another circle theorem to look at. Here it says find the size of angle BDC. Now, BDC is over here, B to D to C, just there. So this is the angle that we're trying to look for. Now this is another variation of a question where you have to kind of look beyond some of the aspects that you can see. So here we actually have a diameter drawn in the question. Normally when there's a diameter in the question, it's because we're looking at angles in a semicircle, or the angle at the circumference in a semicircle, and that forms a right angle. So here we have a right angle. I'm going to write 90 for that, and we want to write the reason that angles at the circumference in a semicircle are equal to 90 degrees. It might be that we are now done looking at this particular triangle, but if we remove that, we can have a look and see if we can see anything else. So as well as that circle theorem, we also have this one here, where we have this almost bow tie shape, which is angles in the same segment. So here we have an angle of 28, which is the same as this angle just here. Just watch out for those, sometimes they can be connected at the centre, and of course angles at the centre are twice angles at the circumference. So here they are the same, and we would say the reason for that, as we've just discussed, and now we've got some other angles. So from here, we can sort of work around the shape, having a look to see if there's anything else we can spot. It might be that we're able to get the angle straight away. If we look back at this triangle that we had in the semicircle, we can actually see that there is just one missing piece in the three angles of that triangle. We have the 90, we have the 28, and we have this 32, which makes up that final angle. So if we add them all together, 90 plus 28 plus 32, we have 150. So 180 degrees in a triangle, take away 150, leaves us with 30 degrees as our final answer. Now there, the rule that we've used is angles in a triangle equaling 180, and we would write that down as well. But there we go, there was just another circle theorem with some different circle theorems in there, just to make sure we get a little bit more coverage of some of the other circle theorems. So of course we need to know how to use the quadratic formula. Our formula is given to us, it's minus b plus and minus the square root of b squared minus 4ac all over 2a. Our values of a, b and c are these numbers here, including the symbols in front of them, so a is equal to 7, b is equal to 8, and c is equal to negative 5. We just need to put them all in place. Do be careful and watch out in case b is negative, because this starting piece is negative b, and it will change the sign. Here it's not, so we have minus 8, plus and minus the square root of 8 squared, I always put this number in brackets again in case it's negative, minus 4 times 7 times negative 5, and that's all over 2a, which is 2 times 7. So we need to type this into our calculator, and we need to do it twice. Now I would advise typing it in very, very carefully and starting with the plus symbol, and then all we need to do is go back into our calculator and change the plus symbol for a minus symbol, and we'll get our second solution too. So when I type it all in using the plus symbol, I get the answer 0.448775 and a few more decimals. It is going to ask me to round it. I'll come back and round it at the end. If we go back, change the plus symbol for a minus symbol, we get the answer minus 1.591632. But again, I'm going to stop there as it wants it to three significant figures. We'll chop it after the third significant figure for each one. So for the first one, it comes out as 0.449. And for the second one, negative 1.592. And there we go, there's our two solutions using the quadratic formula. Of course, you can be asked the quadratic formula as a standalone question, or it can be incorporated into other questions where you are solving quadratics. Okay, and looking at a quadratic sequence. For this particular quadratic sequence, I am going to use the formula for working it out, but regardless of which method you use, we need to find that second difference. So from 10 to 21 is 11, and 21 to 38, that is a difference of 17. That looks like it's going up in sixes, but let's just double check. 61 to 38 is a difference of 23. So there we go. These are, in fact, going up by 6 as our second difference. Now the second difference is always divided by 2. So just as a failsafe, write down 3n squared, as that is 6 divided by 2. Now that's going to get you a mark. Now I'm going to use formulas for the three pieces in my nth term. So 2a is equal to 6. 3a plus b is equal to 11, and a plus b plus c is equal to 10. I just need to solve these, and then they all go in place into my quadratic nth term, which is written in the form an squared plus bn plus c. So if we solve these, we've already got a is equal to 3. I can then move my way up. So if a is 3, this is 9 plus b is equal to 11. So therefore b is equal to 2, so plus 2n. And then we know a and b, so we have 3 plus 2 plus c is equal to 10. That's 5 plus c, so c has to equal 5. So that's plus 5 at the end, as it was at positive 5. So our final answer is 3n squared plus 2n plus 5. And there we go, there was the nth term of a quadratic sequence. Now with algebraic fractions there are so many different variations of questions. This one here is quite a complex one. It's quite a complex one because we have this square bracket involved, and you'll notice that that is involved in some topics where there are brackets inside of brackets. And here we have this x plus 5 inside a bracket inside a much larger bracket. So we're going to deal with what's inside the brackets, or the big bracket to start with, and I'm going to write x plus 5 as a fraction over 1. So x plus 5 over 1, and we're going to times that by the reciprocal of the second fraction, as we are doing a division here. So we get x minus 1, and on the bottom we have this quadratic x squared plus 3x minus 10. Now what I want to do is have a look to see if there's anything I can factorise, and here we can factorise the denominator on this second fraction. So we have x plus 5 over 1, and we're going to times that by, this is still x minus 1, and this factorises to either 1 and 10 or 2 and 5. Now a bit of a hint here is it's likely to match the 5 because we do have a 5 on the top of this fraction. And it is x plus 5 and x minus 2. Now because there is a common bracket now on the top and bottom of two fractions that are getting multiplied together, they can actually be cancelled off before we even multiply them. If that x plus 5 is going to end up on the top anyway, we may as well cancel it before we even get there. So for this one now, we have 1 over 1 times that next fraction, which just means that all we end up with is x minus 1 over x minus 2. Now, it did ask us to add that to the number 6. So now I have to do 6 plus x minus 1 over x minus 2. Now 6 can be written as a fraction, 6 over 1, and we need these to have a common denominator. At the moment, one of them's 1 and one of them is x minus 2. So we can times this left fraction by the x minus 2, which will give us a denominator of x minus 2. We just need to be careful with that numerator there. So when we do this, we get 6x minus 12 over x minus 2, which now has that common denominator and can be added to the x minus 1 over x minus 2. So when we add these together, collecting the like terms on the top very carefully, 6x plus 1x is 7x. And for the next piece, which is just the number there, we have negative 12 add negative 1, which is going to be negative 13, and that's all over x minus 2. So there's our final answer. Be really, really careful, just in case there is a subtraction, because we would be subtracting both pieces on the numerator, which can change symbols. But there we go, there is quite a complex algebraic fraction, and we got to a final answer of 7x minus 13 over x minus 2. Okay, so in this question we're having a look at some bounds, and this one here is in the context of speed, distance and time. So it wants us to work out a speed, and it says by considering bounds work it out. So first of all, we want to make sure that we know our speed formula. So speed is equal to distance over time. Now for this one we have some quite awkward numbers. It says the distance is 10.6, correct to the nearest 0.1. So for the distance, which is between these two values, we have 10.55 and 10.65, going that 0.05 above and below. The time is very awkward because it's written in 31 minutes and 48 seconds. Now if we convert this just into seconds so that we have a number that we can actually write a bound for, well 31 times 60 is 1,860. So 1,860 plus the 48. So plus 48, that gives us 1,908 seconds. Now the speed is in kilometres per hour, but that doesn't mean we can't work out a speed in kilometres per second and then just change it into hours. Of course, we just times it by 60 for kilometres per minute and times it by 60 again for kilometres per hour. So if we write our error interval for the time, let's call that t, and that'll be between the 1,908.5 and 1,907.5. Now, as we are considering bounds, it means that we have to work out the upper and the lower bound. So to get the upper bound, which is the biggest possible answer for speed, we're going to do the biggest distance divided by the smallest time. So 10.65 divided by 1,907.5. And for the lower bound, we're going to do the smallest distance and we'll divide that by the biggest time. So 10.55 over 1908.5. Now when we do this, that is going to give us a speed in kilometres per second. So if we were to times both of them by 60, that's going to turn them into kilometres per minute. And to turn that into hours, we're going to need to times it by 60 again. So rather than writing down loads of numbers here, I'm just going to do it all in one go. So 10.65 on the numerator, 1907.5 on the denominator, times 60, and that comes out as 20.09960682. We need to do the same for the other one. I'm just going to swap the 7 on the bottom for an 8, and on the top the 6 for a 5. And there we go, that comes out as 19.900445538. So these are our two bounds, our upper bound and our lower bound. And by considering bounds, we have to decide on how we are going to round this so that they both round to the same number. So always start as accurate as we can. I can see if I go, for example, to 2 decimal places, they're not going to round the same. Our first one there would round to 20.0, and the 9's going to round up, so 20.1, and the bottom one would round to 19.9. So I'm going to have to go less accurate than that and see if it works. 1 decimal place will be 20.1 or 19.9, so that doesn't work. So we'll go to 2 significant figures, and that rounds to 20, and this one rounds to 20. So there we go, that would be 20, and I would give a reason somewhere because they both round to 2 significant figures the same. I'll put here same to 2 SF. And there we go, that's looking at bounds, and that also involves some compound measures, specifically looking at speed, distance, time here. Okay, so for completing the square, I think a relatively nice topic, we just take this number here in the middle, the coefficient of x, and we halve that and put it into our squared bracket. Keeping the symbol that's with that, so it'd be x minus 3 squared. Now we can either expand that double bracket, or what we actually need is just to think about what number we would get at the end. Negative 3 times negative 3 would give us positive 9, and we just compare that to the expression in the question. This expression wants a plus 1, we would have a plus 9, so we're going to have to subtract 8. So the value of a there is the 3, so a equals 3. Paying attention to the symbol here, it does say minus a, and we've got minus 3, so a is 3. And b is equal to 8, again paying attention to the symbol, it says minus b, and we've got minus 8, so the b itself is just the number 8. So there we go, it does also say here, write down the coordinates of the turning point of the graph, and our turning point is within the brackets for the x coordinate, which is the 3 here, but we flip the symbol, so positive 3, and the y coordinate is this number at the end, negative 8. We only flip the symbol for numbers in the brackets there, so our coordinate is 3 and negative 8. Now for a perpendicular line, we just need to know 2 things. 1, the equation of a line, which is in the form y equals mx plus c, and the second part is knowing about our negative reciprocal. So here we're going to look at this straight line equation. We want it in the form y equals mx plus c. To get it into that form, we'd need to divide both sides by 2, and that gives us 1y is equal to 3 divided by 2, x, or 3 over 2, x, minus 7 over 2. Now we've done that because we want to know the gradient of the line, because if our gradient, which I'll label as m, is 3 over 2, then our perpendicular gradient, which I'll label as MP, will be the negative reciprocal of that. So we change the sign, making it negative, and flip the fraction over, making it 2/3. From here, it's just putting all the pieces now into the place that it needs to go. So for y equals mx plus c, what the y value, which is given to us in our coordinate, is negative 5. That's equal to minus 2/3 multiplied by the x coordinate, which is 6, plus c. I just want to simplify this, which I can do on the calculator as well. So minus 2 over 3 times 6 is equal to negative 4. So we have negative 5 is equal to negative 4 plus c. Can add 4 to the other side, we get negative 1 is equal to c. And now I have all the pieces. I've got the value of m, which we worked out, our gradient. I've got the value of c, which is negative 1. So my equation of the line will be y equals minus 2/3 x minus 1. Now it could ask us to write that in another form. For example, it might want us to write it without any fractions involved, in which case I'd need to times everything by 3 here, which would make it 3y equals minus 2x minus 3. But you could be asked to write it in another form. This one doesn't. It just says find the equation of the straight line that's perpendicular to L and passes through 6, negative 5, and that we have done. So graph transformations is quite a nice topic. It's just remembering a few of those rules. Anything inside the bracket affects x and tends to do the opposite of what you'd expect, and outside the bracket affects y. So here, x plus 1 inside the bracket. Plus 1 you'd think moves right. It doesn't, it moves it left. So that goes left 1, and then the minus 3 affects y, does what we expect, so it goes down 3. So I just need to pick some nice whole number coordinates. There's a few here which we can move along, and I'm just going to move them left 1, down 3. So I'll start with that very left 1. Left 1, down 3 goes to here. The next one here, and then that one on the little dip there, left 1, down 3 goes to here. The next one, left 1, down 3, just here, and then 2 to the right of that is just there. So now I want to join it up, obviously nice and clear, particularly as we're going over the top of the axes there. I want to make sure that bit's nice and thick line, and then the last one, and there we go. So there's my graph drawn in. I've moved it left 1 and then down 3. Okay, so these subject of a formula questions, they do just take a bit of time. You can there's a few steps along the way that we can reduce the amount of time that we're going to take. I'm going to expand the bracket first. Now I need to multiply this denominator to the other side. I can write that as a single bracket, or I can just straight away multiply it by the d there. So df minus 4d is equal to 3 minus 3f. Now I'm going to move the piece that we're trying to make the subject, the f's, to the left. So I'm going to add 3f to both sides, and I'm going to add 4d over to the other side as well. So I'm skipping a few steps here just to reduce the amount of working out. So I have df and I'm adding 3f. The 4d's going, so we have 3, and we're adding 4d to the right. Now all the pieces are on the same side, it just makes it really nice and quick to factorise the f out. D plus 3, which is equal to 3 plus 4d, and now dividing by the bracket to isolate the f gives us 3 plus 4d over d plus 3. Now there is another variation of the answer here, because you can move the pieces with the f in to the right hand side, which will just change the symbols, but the answer will look pretty similar to that, just with different symbols. But there we go, skipping a few steps there to reduce the amount of working out. So I've done that in 4 lines, but you could probably write that in about 7 or 8 lines if you were to write every single step out. But there we go, there is changing the subject of a formula, including some factorising. And looking at a relatively complex quadratic simultaneous equation. Now with a quadratic simultaneous equation, this second equation here, if it's all in this form, needs to be written as x equals or y equals. Now here it is easier to minus the 2y from both sides, which gives us x is equal to 1 minus 2y. We can then put it in the place of where the x is. Just be careful here because we do have 2x squared, so it would be 2 lots of 1 minus 2y squared minus y squared is equal to 17. Now I do want to work out this bracket, and I'd usually just do that to the side. So 1 minus 2y and another 1 minus 2y is equal to 1 minus, we'll get 2y and 2y, so 4y, and then negative 2y times negative 2y is plus 4y squared. Now we are going to do 2 of those as it's 2x squared, so we may as well times it by 2 up here, which gives us 2 minus 8y plus 8y squared. That's now going to be much easier for us to replace in this part here, where we can slot that in. So 2 minus 8y plus 8y squared, and we're going to minus another y squared from it, so we may as well write plus 7y squared in this spot, and then we have equals 17. We now need to minus 17 from both sides so that it's equal to 0, and we probably want to arrange these so that the y squared is written first. So let's arrange it so that the 7y squared is at the start, the minus 8y is in the middle, and 2 take away 17 is minus 15. Now that is equal to 0. Now at this particular stage, if you are using a calculator, then you can just use the quadratic formula. However, you can always see if it factorises. This one here looks like it might factorise, so let's have a look. 15 is 1 and 15, or 3 and 5. Now to make negative 8, we could times the 1 by 7, so we could have the 1 over here, the 15 over here, and we'd want to make minus 15 plus 7, and that would make negative 8. So that gives us two values of y. We have y is equal to 15 over 7, and y is equal to negative 1. We then need to substitute those values back into one of the equations. We've already created a nice one here. We have x is equal to 1 minus 2y. So for the first one, we can do 1 minus 2 times negative 1, and that gives us positive 3. We can also do 1 take away 2 lots of 15 over 7, and typing that into the calculator, we get negative 23 over 7. So we get two sets of values here. We get when x is equal to 3, y is equal to negative 1, and when x is equal to negative 23 over 7, y is equal to 15 over 7. So there we go, quite a complex quadratic simultaneous equation there, but I think writing that working out to the side for this portion of the question here did simplify that a little bit, and obviously making sure when it comes to solving the quadratic here, if you're not factorising it quickly, just use the quadratic formula. Okay, and the final topic that I would just make sure that you do have some revision on, particularly if you are pushing for those higher end grades, then here you have those really tricky vector questions where you have scalar quantities involved. Now I have done a video on this. It does take a long time to go through each question. Each one can take 10 to 15 minutes, particularly when you are explaining them as you go, but I've gone through 5 of some very, very challenging vector questions that I will link in the description right next to the timestamp for this part in the video. So do check out those particular questions if you did want to have a look at some vectors, but otherwise that is the end of the video there, and I will see you hopefully for our practice papers the night before the exam, and you've picked up some good tips from this video, but otherwise best of luck, and I'll see you for that next video.